Good evening, everybody, and welcome to our first meeting of 2025. Tonight we have Liz Jennifer. I used to work with Liz at AHDB quite a few years ago now. Liz has a strong technical background and works with both beef and sheep farmers across the UK. Her knowledge covers livestock production, grazing systems, sustainable farming practices, and she works with farmers who want to challenge their current practice, particularly on grass and forage utilisation. She's one of the founders of Carbon Calling, which aims to build a community of farmers to support and learn from one another to make their farm and themselves both happier and healthier. She is a farmer with a family farm which is a mixed farm in South Lincolnshire, and she has an Australian cattle dog called Scout, which I've seen trail the country in many places that she's been. So without further ado, Liz, I'll pass over to you to teach our Prism farmers and other ABP farmers how to grow more grass. And if anybody has got any pertinent questions as we go through, if you could just write them in the chat, and obviously if I think it's relevant for that particular moment, I'll ask it at that point, or if I think Liz might be coming on to it, then we might just leave it and we'll ask the questions at the end. But if everyone can stay muted, that'd be great. And over to you, Liz. And then obviously we've got questions at the end as well.
Thanks, Katie. Just to check, it's full screen and my slides are happy.
Yep, I can see and hear you.
Thank you. Good evening, everybody. There's quite a few familiar faces and names on the call, so hello. I'm sure some of you may have heard me and seen some of these slides before, but we'll give it a go. So the topic, as Katie mentioned, is grow more, graze more. So the plan for what I'm going to go through, and the aim is to talk for about 40-ish minutes. And as Katie said, if you've got queries or things that are coming, put it into the chat, and then there'll be some time for questions at the end. So I'm going to do some, welcome, Katie's done, and some intros. I'm briefly going to talk about the carbon, biodiversity, water and soil, because this is within the Prism programme is the key parts of all of that. And grazing, albeit not mentioned specifically, sort of overlaps through all of those different bits. So we'll talk a bit through that. I also encouraging you to work out where you are now. So the assumption in all of this is that we always need to get better, but actually what we also need to do is work out where we are, what's working well, what's not working well. So, and you don't necessarily need to share this, but I'm encouraging you to grab a piece of paper and a pen, and I'll ask you some questions in terms of reviewing what was happening with grass, forage, conserved forage during 2024, and what your plans are for 25. And then thinking about how we measure. So a lot of this is to do with what is your question. So we can, and Katie and I have both done in our careers, talk to people about all of these different tools and techniques you can use to measure grass, but actually that might not be important for what you wish to achieve on the farm. Some of the time it is, some of the time it's about understanding what that actual question is and what your needs are. So we'll also talk through that. I'll give you sort of an overview of grazing systems, and why it's important to have a range of tools in your toolbox. So when is the most appropriate time to use a rotational grazing system? When is set stocking okay? I've got a brief slide on herbal lays just because it is a very common source of conversation at the moment, particularly for people who have established them or are establishing them through SFI options if you're in the UK, and there's other schemes as well. So, and that's generally what we've learned from talking to farmers, experiences, and just to share that really. And again, if you've got things to add on herbal lays, please put them in the chat function when we get to that section. And as I said, there's some questions and a bit of a summary at the end. So, and I know I am obsessed with grass, but I'm also getting more and more obsessed with soil. And what we have to understand, if we get the soil right, we get carbon, we get biodiversity, we get water management happening. And so for me, it always starts with the soil. So if we are really targeting biodiversity, we need to understand what the soils are doing and how we manage our soils to try and enhance that biodiversity. We'll come on to that in a second. Traditionally, we view soils from a chemistry, physics and biology perspective. So chemistry is what nutrients are in that soil, and we're starting to get a whole different range of thinking. A lot of it's coming from the agroecological approaches or the regenerative approaches or the biological approaches to soil. And that we're learning a lot more about how those soils are dealing with nutrients, how we can try and reduce our fertilizer input if we're getting that soil health improved. Physics is structure, and that generally is determining how much air we're trying to get into the soil. We would like soil to be about 25% air, and a lot of farms, that compaction or consolidation of soils is limiting that grass performance. So digging holes, understanding what's happening within soil and how it's structured is crucially important. And biology, probably up until a few years ago, it was always a bit of a throwaway. Oh yeah, and there's also biology, and we sometimes count worms. And it's becoming a core part of what I talk about on farms and what farmers are becoming more and more interested in. How do we enhance the biological function of our soils and what impact that will have, both in terms of performance of grass, but also profitability, because we can hopefully reduce the bills that we're paying. What we tend to see, and again, if we're looking at from a sort of quite a traditional viewpoint, is we're tending to see soils that are lower in P, K, and magnesium, generally not magnesium, sorry, P and K, than ideal. And so what we're also interested in is this, sort of biological approach of seeing actually whether we can unlock some of those nutrients that are in the soil but are currently not available to the plant. So it depends on, can be a bit of a Pandora's box, and once you've sort of seen what's in the box, this analogy is not going well, you can't ever go back. So it's still really trying to target people to understand or become interested and curious in terms of what's happening with their soil, because without that, whatever future farming systems will be, soil health will be a core part of it. And how do we measure it? So we talk about water infiltration. We can all potentially, if some of you may have already have hit an infiltration ring into soils and measured how quickly that water moves through. We can dig holes. We can take different samples for bulk density, which is sort of basically understanding how much air, sort of what airspace is available. We can do the standard tests that we do, so pH, nutrients. We can start to look at the biology, so we can count earthworms, we can look at nematodes, we can look at microbes, or certainly have an interpretation or an assessment of the microbial activity of those soils. And we're also seeing whether there's anything in that soil that's causing an impact from a plant health perspective. So that could be something that's eating the roots, or some fungal disease that's causing an impact from a grass yield perspective. Organic matter, and we have to recognise that organic matter is around about 50% carbon. So when we talk about carbon in soils, we're talking about organic matter generally. There is two forms that carbon gets into the soil, and that is through dead plants, dead animals, dead roots, sort of things that have lived and are now decaying into that soil. So it could be leaves that haven't been eaten or trampled in. That's one form of organic matter. Another really important form of carbon that comes into the soil is actually through organic carbon, so generally acids that are leaked out of the root structure. So that generally happens when the plant is in a healthy state and soil health is functioning well. So we tend to prioritize the trampling. How do we get as much organic matter in at the top end? And what we're sort of trying to get to is actually how can we get that plant to function better and feed the soil biology that is around that root structure. And that's the bit that we're starting to get onto we're trying to get onto more farms with some of this thinking, and how do we actually get it onto more farms from a practical perspective. So there's lots of YouTube, and I'm sure there's people on the call that have already happily investigated what their soil health is doing and have become more and more interested in how they get carbon lockdown into their soil. So this is the soil food web, and I will move on to the actual topic in a second, Katie. So this is the soil food web, and when we talk about biodiversity, we tend to think really interesting things about beavers or massive trees or things that we can really readily see, and we're trying to get more wildlife onto farm. What we're also trying to realise is that actually the main focus of our biodiversity sort of interest should be actually what's going on in the soil. When we start to look at quite a lot of grassland soils, we assume they're fine because they're covered in grassland. or covered in grass. But what we're still trying to see is that we don't have this complex food web under those soils. It's probably easier to achieve it in grass soils than it is in arable, but certainly don't assume just because it's covered in permanent grass that this complex soil food web is happening below. So for me, it's about focusing our interest from a biodiversity perspective into what's happening in the soil. Once we get this functioning, the biodiversity above the ground starts to increase, because it's this is what's fueling that increase in biodiversity. So there's more insects about to feed the birds, to feed, and to sort of have this cascade impact. So yeah, definitely focusing on what's happening under the soil is an important place to start. The other thing we've got to recognise is that particularly grassland is a really, and from a beef and sheep perspective, we have an incredible benefit that we have land that is capable of sequestering carbon. So when we look at it from a carbon focus perspective, we're always trying to offset what those emissions are from the rumen. So grassland, we have a capacity to store and to capture carbon under those in grassland. What this shows, and this comes from a Natural England report that's quite old now, but the principle is the same, which is under grassland, we generally will store around about 0.5 ton a year. If we start to put clovers in, or we start to potentially improve that rooting system within that soil, we start to gather or generate more storage capacity, so that might go up to just under 1 ton. If we're converting grassland to arable, no surprise, and this slightly depends on the cultivation used, but we're generally oxidizing that organic matter that's in the soil, and we're releasing CO2. There's a big land use conflict with a lot of woods going into grassland, and that grassland is no longer available for grazing. And what you can see, it's actually not doing a huge amount in terms of storing carbon under the soil, but it's to do with the biomass that's visible above the soil. Arable to grass, you see this big increase, and then you've got arable to woodlands, you see that big chunk, and that's generally because the land use has changed quite dramatically. So again, we are in a fortunate position. If we get our grazing right, we are able to store carbon, and in certain situations, depending on the calculator you're using, becoming net zero. You're basically storing more carbon than your farm is releasing. So that's the sort of intro, and just saying that why soil grassland is important when we're talking about all of this range of interests from a sort of public good, and also this wider view than rather than it just being production focused. So my question to you, and this is why you need the piece of paper and a pen, is in relation to grass, how was 2024? So the questions to ask yourself are, what worked well? So did you have a really good grass growth year? Did you have good silage quality? What worked really well? And again, very happy for you to put this in the chat if you're willing to share. What didn't work well? So I know some people, particularly depending on where you were in the country, autumn establishment was really struggled because it was very dry and then very wet in a relatively short amount of time. So again, it depended on where you were in the country. It could be that some people struggled with silage quantity or quality, and certainly there was some feedback that just wasn't quite enough sunshine to drive high D values in silages. And what factor has the biggest impact on stock performance or profitability? So that again in 2024, and hopefully in terms of focusing onto grass, and generally the response to that question is generally weather, and that's why I've put the subsequent question about, is it under your control? And to be obviously the weather isn't, but what we can do is to think about what species and how we manage some of that grassland to help us mitigate some of those issues in terms of extreme weather events that we're starting to see, not to be overly dramatic. So yeah, so those 3 questions: what worked well, what didn't work well, and what from a grazing perspective do you think had the biggest impact? And what's useful about that is then we use them to start thinking about this question.
Liz, can I just ask a question? Can I just ask a question about the sequestration? Dowie's asked, does the amount of carbon that can be sequestrated each year by grassland depend on the existing level, and where does it level out? So
the assumption tends to be that it levels out when it reaches an equilibrium where your practices have stayed the same. So if you, for example, are set stocking a grass field, potentially that carbon sequestration level has reached a plateau. So you're not really adding to that within the soil sort of profile. If you then decide you're going to do some rotational grazing, even if it's for a couple of months of the year, potentially that's a kickstart to start increasing that carbon that's being sequestered into the soil. We obviously are going to reach a point where if we go a lot higher, we're turning land into organic soils or peatland, which is not necessarily what we're trying to achieve. So there is an element of plateauing, but what we're actually interested in is getting it down to depth. So quite a lot of the measurements that we do or have been done is measuring organic matter in the top 10 to 15 centimeters, because that's quite easy to measure, and that's what a lot of soil tests are being taken from. But we're seeing this really long-term storage of carbon is at depth, and that's when it's sort of 15, 20, 25 centimeters down. And again, depending on what your soil depth is and what your subsoil and all of that is, that's quite a lot of volume that we can still be putting carbon down. So I do think the top probably saturates quicker, but the at depth bit doesn't. And what's interesting about the carbon that's being stored at depth is it's quite secure from cultivations. So that stuff in the top 10 to 15%, when you start to cultivate, it's really quickly oxidized. If that carbon is locked down at depth, it's not readily lost when you start to do cultivations. But I think the answer is, I don't think there is we've reached 10 and we've stopped, because we're dealing with a biological process. So when we change practices, it might go up and it might go down. And that's why banking everything on carbon sequestration is challenging, because it's variable year on year. But I would argue that most grassland soils can still cope with a bit more carbon, but that carbon would be to depth. And so if you have the opportunity to do soil cores on farm, which are going down to 50, 60 centimeters, you'll see that carbon level does reduce when you go to depth. And that's the bit that we really need to drive. And that comes from products that are leaking out of roots. That doesn't come generally from stuff that's been trampled at the top. That's a long version of that answer.
Thanks, Liz.
So just follow on from that. So that those tables are net. So there will be some respiration. There'll be some losses. So CO2 is released from the soil. It sort of breathes out CO2 as well. But that is a net figure. So you're capturing more than you're losing through respiration. Oh, there's some thoughts in terms of what's worked well. So for 2025, the ambition is to take the things that haven't quite worked in 2024 and to then think about what can we start to tweak. And this is just an example from a meeting I did a while ago. But this is a technique that I still use, which is this keep, improve, start and stop, because fundamentally we can't keep adding more and more entertaining technical activities onto farm. We occasionally have to stop doing things that's not working. So the stop is equally as important as the start, because it gives us time to achieve what we new practices that we're trying to get onto farm. So this example was about, the keep is about recognizing what you're doing well. So what did work well? What do you like about your current system? The improve are things you're already doing, but you might need to tweak. And 9 times out of 10, that involves infrastructure when we're talking about grazing systems. Things that are start doing, so ideas that you've seen elsewhere, ideas that you think would be useful on the farm. And then the stop doing is things that aren't quite working well, that aren't helping you achieve that stock performance profitability angle that we talked about at the beginning. So stop can be sometimes quite difficult to do, but it's quite a useful technique to think about what's worked well, what hasn't in 24, what are some focus areas for 25 in relation to grass. And I accept that whether we can't always make the best predictions in terms of what grass is going to do, but we can start to identify those target areas. And I normally start with 2 or 3 places rather than deciding we're going to change the whole farm in a year. And this is back to what are we actually trying to, what is your need? So this could be driven by supply chain. It could be that you have a target in terms of the grazing days. It could be in terms of the proportion of the diet that has to be from forage. So actually, what are the core things that you're needing to look at to satisfy either a supply chain question or something that you're really interested in pushing up live weight performance per hectare. So where are you now? Where do you need to be? What's realistic? What's an industry benchmark for that? So again, this is not saying that you need to do all of these. This is saying what is the one or two things that I really want to focus on in 24, and how am I going to go about understanding where I am now and where I want to be. The slightly cheeky thing at the bottom is that there's still a lot of people who are taking pictures of themselves near a grazing system and put it on Instagram. If that's what motivates you, crack the hell on. But it's also about what is driving profitability on farm. And sometimes outwintering is, sometimes it's not, depending on that level of repair you've got to do after those animals have been over that land. So again, it's what's your question? What are you trying to target? Again, I'm happy to take questions in terms of all thinking through things with people if they've got particular areas they want to focus on. And this is some of the tools that again has been promoted in terms of measuring and monitoring. And again, it doesn't necessarily have to start with measuring grass, but it does get us a feel for what's happening. And I think the bit that's most interesting is if we do it regularly enough, we're starting to get interesting information about how different fields are performing, and it allows us to target fields in terms of from a soil perspective. So it could be, is it struggling from a structure perspective or a nutrient perspective? That's where it becomes quite powerful. So yeah, and again, it can be as simple as a sward stick. It can be as complicated as some satellite imaging. So there's a whole range that we can approach grazing systems with, but it's still back to this: what do you actually want it to achieve? What's your question? Is this the right thing to answer that question? Sometimes it is, sometimes it isn't. And why do we need to focus on grass and forage? And it comes down to, generally, it is the cheapest feed that can go onto farm, and increasingly consumer perception. So within that supply chain, there is now added benchmarks, that's not the right phrase, targets to us in terms of that a level of grass and forage. And this used to be a 1 to 3, 1, 2, 3 rule. So what we tend to see is graze grass. We could generally say it's around about 10p per kilo dry matter, and that's generally on a improved lay type system. So we can, on a permanent pasture system, get that a lot cheaper. But generally, for easy maths, let's work on 10p a kilo dry matter cost, and that includes fertilizer if you're using it. It can has a depreciation in terms of reseeding. All of those things are being captured in that number. If we put it into a bale or a clamp, we tend to double the price. So it's coming out at 20p per kilo dry matter. And again, you may have these calculations for your own farm, so please put them in the chat and challenge me if you so wish. And bought in feed, again, it varies and depends on what bought in you are and whether you're using it and how you're using it with your supplementary feed. But we're generally working on a high 30 to 40p per kilo dry matter. It has dropped a bit, but it's still on this 1, 2, 4 rule. And that isn't saying thou shalt never feed anything else. It's just saying we're trying to prioritize the amount of grazed grass or forage in those animals' diets, and that we then strategically use that conserved grass or bought-in feeds or home-produced feeds to put extra finish on those animals, or to finish them at a different time of year, etc. So I'm definitely not saying thou shalt never feed anything you can feed other things. Grass is great, but you sometimes need other things. And this, a very simple view of what grazing systems could look like. Katie, this may be familiar to you. So we have a set stocking system, and we have to be careful that people are now associating set stocking or continuous grazing with being negative. And sometimes a year, particularly with sheep grazing, it's actually the best thing you can do from an animal performance perspective because it's reducing stress. That doesn't say you can do it all of the time necessarily, but at certain times a year, it is the most appropriate system. We can then move to sort of weekly shifts, so we can start moving animals round systems, but we're doing it in a relatively sort of weekly or every 5 to 7 days, something like that. Or we can go to systems where we're moving them more frequently. And that could be something that we're doing in the winter, because that allows us to all grass winter. It could be something we're doing with lambs or grazing cattle. So again, it's not about one grazing system has to fit across the whole farm. It's about choosing the most appropriate one for what we're trying to achieve from that class of stock. And the infrastructure, and we'll come back to it, it always comes up because people can either spend time or money. That's the principle. So you can either keep moving fences, or you can invest in some semi-permanent or some slightly different ways of doing stuff. But for me, the concept of moving a fence, if you don't like the idea, this is not the thing for you to achieve. So and that isn't about allowing or not challenging. This is about understanding where is the best place to prioritize. And what's interesting when you go and see people who have started to prioritize fences and moving stock more frequently, it does save them time. But it is about investing in some kit to get you to that stage. And generally what it also means is you're going to be growing more grass. You can run more stock, and all of those factors start coming in. So, and this is just trying to illustrate when we're dealing with we're generally dealing with groups. And as we go through this, we're dealing with more complex groups. And why I say complex, so the easiest group to manage is a group of dry stock. I mean, their requirements are quite low. Generally, they're not necessarily lactating. They might be just pregnant, but again, their requirements are relatively low. You can change the group size really easily. So if you think your rotation isn't quite what it needs to be, you can take out 20 animals and it has no impact. And then as we move through to more complicated groups, so ewes with young lambs are quite complicated group to manage on a grazing system, purely because they're quite prone to stress. We're desperately to try and avoid mismothering, and those animals are trying to grow as fast as they possibly can in that early stage. And they're really difficult to adjust group size. So if you've decided that you've got too many animals for the rotation you're planning, it's really difficult. It's not impossible, but it's quite challenging to pull the ewes and their lambs out of those systems a lot of the time. So the worst case I tend to see is when people start rotationally grazing at lambing time, and the first group they're doing it with is ewes and lambs, because you're about to experience a really explosive grass growth situation with a really complex group. Well, a lot of people start that sort of journey into rotational grazing with an all grass wintering system where you've got a group of dry ewes, relatively big groups, are easy to manage, and again, really easy to adjust. So again, think about if you're going to start, what group are you going to start with, and how complex is that group in terms of its needs and its ability to change the number. And that's the untrained stock, the ones that get out, the pain in the arse. And then in terms of prioritizing stock, this is looking at which animals are we trying to maximize growth rates performance on, and that always tends to be the growing animals. So that could be ewes and lambs, weaned lambs, growing cattle. And I tend to put cows and calves slightly lower down that priority because they can deal with slightly rougher stuff. A cow's rumen's larger, it can deal with slightly more mature material than necessarily sheep can. And then we're moving through to which are the ones that we're not prioritizing necessarily quality on. And so to clarify in terms of quality, I'm tending to think about leaf. So when we have a lot of green leaf in clover, we're talking high quality, and that's what's going towards your ewes and lambs, your growing animals. When we're talking about stem, we've dropped energy slightly, and that's going to maybe a suckler cow plus calf type system. And then where we've got slightly different quality grass, and that's can be a lot of dead, a lot of stem, we're going to go use that for a dry stock tidy up. So again, throughout that season, not only are we approaching it with different grazing systems, we're also adjusting which animal is getting priority and how we're using certain groups of animals to improve the quality for something else. So we generally, the idea that if we have cattle within a sheep rotation, we get an extra 50 grams of growth rate on those lambs because they're helping to improve the quality of that next rotation because they're taking out the taggy stuff. and they're also doing a dilution effect on parasites. We also know the power of those dry ewes to hoover up parasites for the lambs that are coming through, so we can use cluster stock to do jobs throughout the year. And we also have a range of strategies of what we do when grass is growing. It's interesting when we sit here in January and think grass is never going to grow again, that come May or June that we are dealing with a slight high grass growth situation. So depending again on the time of year, we can start to set that up from a deferred grazing perspective. We're taking silage off. There's an example at the bottom right, which is this basically going through and mowing it before those animals go in, and so that increases their intake of that grass once it's wilted slightly. Pre-graze mow, yeah. So there's a whole range of things we can do in terms of techniques, and what we're always trying to do wherever possible is to reduce the costs of what we're trying to achieve. So the easiest thing is that an animal eats it rather than we have to fire up a tractor and do some work with it. So again, deferred system and then feeding it back gradually is an important way of dealing with this. So again, I've talked about rotations, and again, at certain times of year, it's appropriate to use them. For a lot of growing animals, it's a really good way of allocating high quality to them and sort of keeping in control of quality. There's a couple of examples where we're showing this benefit of rotational grazing, and there's another recent study out of Northwick that shows the benefit that's not on here. But again, we're seeing this increased value per hectare. Challenge tends to be individual performance is less good when we move to rotational systems, but per hectare performance is better. So we're able to push up those stocking rates. The lambs may not grow as quick, but we're having more of them per hectare, which is where some of these benefits are coming from. And the same can be said for cattle. And a lot of that is to do with how well we're allocating. So how much feed are we putting in front of those animals and how well are they converting it? Quite a lot of the challenge that we see on poor growth rates, particularly on growing animals, is that we're trying to ask them to tidy up pastures too much. So we're basically trying to get them to go through pastures and choose the best bits. And generally animals can select a diet that's probably 1 megajoule higher than the analysis that we do. If you push those animals through and you allow them to select the best bits, that's when their growth rates are higher. If we're asking them to do that plus to tidy up, that's when we can start to see some reduction in growth rates. And that's where leader follower system, so where you've got the main priority group goes through first, and then a second group comes and tidies up, and that could be a group of dry ewes or cows and calves, depending on what you've got available at the time of year. And the reason why rotational grazing works is because it works to what the plant needs. So this is an example from ryegrass, but the same principle holds true for most productive grasses and also clovers to a certain degree. That ryegrass will only ever have 3 leaves, so once it gets to its 4th leaf stage, that first leaf dies away. And the most effective grazing for those plants is when we're getting to basically to the 3rd leaf. They've got maximum photosynthesis capacity, and just before that, we're starting to lose some utilization with those leaves dying off. Obviously, there's plants that do that all the time, so we're aiming for perfection, but rarely get there. So that's partly to do with just this root reserve. So we're trying to work wherever possible with that plant. So why rotational grazing systems grow more grass is because of this rest and recovery. They've eaten the plant down and they're allowing it this recovery period. So some of you may be interested in sort of taller grass grazing systems. So the principle is the same, but we're taking those plants to a higher maturity level. But the principle of rest and recovery is still with us. And if we continuously graze it too short, those plants just don't have the capacity to take as much sunlight in as the ones with the longer, larger leaves, which is what we tend to see in these more rotational grazing systems. The other thing that we've also got to identify is there's a range of production on those farms. So I encourage quite a lot of the people I work with to sort of, we're going to map the farm. We're going to understand where the areas are that we can push or that we need to improve, and so it just gives us we all love maps. It just gives us a focus area, and also this, when we start to see it mapped out, we can start to see natural rotation. So is there fields that work together, rather than necessarily thinking of the whole farm as one rotation? We try and break it up into almost farmlets and run rotation slightly separately. So again, it's a lot easier to see when we're looking from a map perspective. There's also opportunities to, if you're from a biodiversity perspective, we can also highlight fields that have ground nesting birds or that are really important at certain times of year not to be disturbed. So we can also plan that in if we're starting to think from a holistic planned grazing approach. But again, it gives us this idea of how we're going to get this balance between grazing and biodiversity. Infrastructure. Everybody I speak to about infrastructure always says they wish they'd just spent the money earlier, because generally it is saving us time. There's a lot of debate in terms of infrastructure. There's been some grants out and various capital works and all of that. So there's quite a lot of infrastructure going in. And so some of that is just making sure, well, a decision has been made. There might be some feedback from some of those decisions, but there's been an opportunity to put a lot of infrastructure onto farms in the last couple of years, particularly in England. And this return on investment is huge. So if we're thinking about it, that it's trying to improve the utilization of that grass, so realistically we might get probably half a ton to a ton extra grass easily from changing a rotational into a more controlled rotational system. And so if we're having to then substitute that grazed grass for either a conserved forage or a concentrate, that's where we start to see that return on investment of that infrastructure coming in. So that's just illustrating the potential gains we can get if we're using grazed grass versus the higher cost feeds. So again, from a grazing perspective, this is a very traditional way of thinking about it. So in terms of sward heights, and this is for rotational systems, and this is for continuous. And this again is not necessarily taking into consideration interest in taller grass grazing systems or mob grazing, but again, slightly separate conversation. But what we're generally seeing is that grass that's going to cattle is slightly longer, but still you're grazing down to 5 to 6 centimetres. For sheep, slightly shorter at 8 to 10. You're grazing down to 4 to 6, depending on the time of year. So it's in relative, not huge changes in sward height, but you're again working with what the plant needs, and you're also trying to achieve what the animals are trying to do. And that, in most systems that we're running, is maximising feed intake for growing animals. So this, if you're more familiar with pasture covers, so this is about 1500. That's about 4 centimetres. So in a lot of sheep systems, that's sort of the out for rotation. It can be at spring, sheep can be maintained at that level. Below that level, we're needing to put in supplementation. 2000, again, which is, if we could just keep fields at about 2000 all year, well, life would be happy, but it doesn't quite work like that. 2.5 is sort of 8 to 10 centimetres, so the grass is just starting to turn over if you look across it. And again, that's sort of heading towards more cattle grazing territory. 3,000, 3.5. So, and some of these pictures are coming out of grazing systems. So again, if you're running quite intense daily shifts with beef cattle, you might be getting up to some of these pasture cover. But it's to do with how quickly those animals take it from that to that, and you're adding in some competition. There's just a point about allocation. So again, we've talked about prioritizing animals in terms of what their growth rate expectation is, but also if we have a lactating or grow animals, they will eat more. Physiologically, their rumen empties quicker, so they can eat more. So to really achieve that performance response we need to try and encourage that feed intake, and that a lot of it is to do with allocation. So making sure those animals are well allocated grass, and that is related to that sward height. If that sward height's dropped, particularly for sheep, lactating sheep, then we might have to put in some supplementation. In the last couple of slides, really, in terms of the other thing we've got to think about is where are the gaps? And generally, depending on where we are in the world, we'll have a gap in the winter. We might have a slight slowing down of grass growth in the summer. And again, as weather patterns change, this is also changing. So when we start to think about as a whole system approach, we're trying to think of actually how can we move grass into certain areas of the year without adding cost. So deferred grazing is a good example, but also we can, where appropriate, put in particular crops to do that. And this is changing slightly as more herbal lays are coming in, because these quite focused, this more specialist crop is dropping really. This is white clover. We know it grows better in the summer, does really well at high soil temperatures, and so yeah, it's an opportunity to have white clover in most swards. Red clover becoming more common again with more herbal lays going in. Traditionally wasn't within a lot of grazing lays, but now starting to be. You just have to be quite respectful because it does tend to die out if overgrazed. Chicory, again, been talking about it probably for 15 years, which is terrifying, but can be useful, can be a pain in the arse. So it now splits the crowd from a Marmite perspective in terms of if people are putting it in. And certainly for herbal lays where you're might be silaging them, most people are choosing not to put it in just because of the concern they have around silage time. Very bad photo of plantain. And then there's a brassica type crop. So again, the advantage of rumens is, yes, they produce methane and we are being ostracized for it, but that rumen allows them to eat a wide range of feed stocks. And so we can use that where appropriate in that whole system to try and make sure we're hitting what the animals need, but also allowing us to have a more diverse rotation, thinking about how we're going to improve organic matter potentially. And the last thing really to say is about herbal lays, and this what we're sort of learning from herbal lays through quite a few years now of using them is that this infamous spring or autumn establishment can be quite tricky, and a lot of the time, particularly with the SFI options, so SAM3 would be one, is a lot of it is going into arable fields, and so actually most of the time we're trying to establish it in the autumn. And what we tend to see from that is that we can get fewer herbs just because the soil temperature is dropping. So there will be differences if you establish them at different times of year. You can get slightly different plant types dominating. So that's the one thing to think about. Equally, we can have dry autumns, we can have dry springs. So then none of it is a guarantee, but certainly what we're seeing is this slight shift in what plants are dominating if we're going for autumn, and general preference is autumn if you can, just because of that there's slightly less flush of weeds coming through. The species, there's a really important thing that we've got to try and work out which species fit our farm and our system. I was talking to Francis Dunn a while ago, who does a lot of seed sales, and his thoughts are that plantain and yarrow are relatively robust in most systems. But some of this is about trial and error, and certainly what we tend to see is that if we're not allowing them a long enough rest period, and the advice now is for that rest period to happen in the autumn, particularly if we can with a SAM3, is that those species will disappear quite quickly. And if we're overgrazing them, particularly with sheep in the winter, we can kill out those herbs within a season. So that a lot of the questions I'm getting on herbal lays is they don't last. A lot of the time is because it's how we're grazing them and not allowing them to have that rest period. And rest period is where those plants are allowed to get to full maturity, to almost a set seed. And that means that they've tried to put maximum root reserves down. And so it gives them just more resilience in that system. So where we're grazing it like grass, so relatively short, we end up with grass. And we can end up with grass within about 6 months. So generally they need this rotational grazing, they need a rest recovery period, and that rest and recovery period changes as we head across the season. So it can be relatively short in the spring, so 20-30 days, increasing to 40 days summer, and then by the autumn it might move up to 60 days. So again, they're just more complex to manage, but the benefit is reduced nitrogen, if zero nitrogen requirement, and in terms of that diversity of rooting system is doing hopefully wonders for the soil. So the longevity is none of these, apart from the perennial grasses, most of the herbs that are being drilled are 2 or 3 year. That's how long they live. So we can't necessarily expect them to live for 6 or 7 years, just because that's not what the plant does. And generally they fit really well within a rotation, or assuming that you're going to have a herbal lay for the first 2 to 3 years, and then after that you're going to have a really good grass white clover lay. So you sort of build in that it becomes something after it. So just making sure in terms of you're hitting your scheme objectives. And most in the original GS4 there was 0 fertilizer. Within the SAM3 option, again, apologise if you're not in England and don't know all this abbreviations, is there is a little bit of fertilizer that is allowed, but the objective of this is to try and get to a point where we're reducing the amount of nitrogen that we're using on farm and getting that nitrogen from the legumes that are contained within these lays. So the challenge is to those farmers that are using herbal lays to reduce the nitrogen inputs. So that's me, Katie, and that's just to remind people in terms of the a technique we can use to try and think of what we're going to do in 2025.
Okay, thank you, Liz. And if we, I'll ask Liz if she can send over that where we're going to focus in 2025 as a Word document. And when I circulate the recording, I'll send that through as a Word document so that you can have it there to hopefully jot those things down. If that's all right, Liz, if you've got that as a Word document. Paul did have a question earlier on. I don't know if you want to unmute and say it, Paul, or whether you want me to say it. I'll give him a second.
No,
Yep, carry on.
Yeah, sorry. No, I was just wondering if you're reseeding grassland back to grassland, is it better to just spray with the Roundup, or like burn the ground off and direct seed, or to plough? Which is the best for increasing carbon? To just plough and put the carbon down into the ground, or you know, I was just wondering which is the best option for increasing the carbon in your soil.
So for me, carbon is something I think about, but it's about 4th on the list. So my first one, when I'm thinking about how that field's going to be reseeded, is have I got a soil structural issue that the ploughing would help me rectify? So if the soil structure is excellent, then why do I need to move that soil? So therefore it can be a glyphosate, or you might go through a brassica crop and then go back into grass. So for me, the question is, what's happening to the soil, and could that ploughing help? So what we know from ploughing is that it will generate, because it's turning and sort of exposing quite a lot of this organic matter to a lot of air, some of that carbon is going to be oxidized into CO2. But what we generally see when we're doing a relatively rapid reseed is really quickly that a plant community is re-established into that soil, and that's what's important. That living root is important because the plant is obviously breathing in CO2. So although that CO2 is being released by the soil, some of it is being captured by that plant. So, and some of this is we can have fights, or I can generate fights in rooms where people go ploughing is evil, and then other people have read what glyphosate's doing to the world, and they would say actually ploughing is the least of the problem. So for me, it's not one or the other, it's the most appropriate thing for what we're trying to achieve. And if the soil structure's fine, or we've got lots of rocks, or we're going to cause more chaos, then why are we going to plough?
That's fair. Thanks so much.
And for the carbon bit, it's we're just trying to get a healthy plant population. So some of the challenges where we're leaving that soil fallow for a long time, we're losing carbon and we're not capturing any because there's no living root working in that soil.
Okay, thank you, Liz. Has anybody else got any questions for Liz? There must be more questions out there from you guys. Do you want to just use your raise your hand function if you want to then unmute and say your question, or type them in the chat?
Oh, Mike's going.
Mike, you just unmute yourself, Mike, and then you can.
Yeah. Hi Liz, thanks for that. Very good as always. Is there like an industry standard way of measuring infiltration that we can do ourselves?
Yeah. If you go, I don't know whether any of you have used Soil Mentor, but if you Google Soil Mentor, one word, if you then look at on their website, they have a thing, I think it's called Soil Test. I'll send the link to Katie, she can circulate it around. And on there is an infiltration test. And it's basically the diameter of a flue. So if out of a wood burner, that diameter of a flue, you hammer into the soil, you pour in a known quantity of water that's roughly about 450 mil if you've got that diameter. If the diameter of the pipe is different, you obviously have to put more water in because you're trying to replicate an inch of rainfall. So then you pour the water in, you time how long that first inch takes to disappear. Then you pour in a second inch of rainfall, and that's the one that's the one that's the record. We record the second inch because the first inch sort of re-wets it, and it's the second inch that's interesting. And so if we've got soils that are not moving an inch of rain in it's basically taking 15 minutes or longer to move that second inch of rainfall, that is suggesting significant issues with water infiltration. And that is
go on, sorry,
but the guidance is on that sort. That's one I use most. It also provides some baselines on it, and also will give you of how to convert that time taken for that inch to disappear, and what does that mean in terms of inches that can disappear in an hour, and I can't remember the calculation.
Okay, thanks.
I've managed. It has to be quite a heavy duty thing. I've managed to buckle a couple. The best I found, you can get the posh infiltration rings. I got some, and again I'll send the link via Katie. I basically went to a steel pipe manufacturer and just got them to send me them in chunks, and that was the cheapest way of doing it. It worked out to be about £9 a ring versus £50 if you're buying a proper one.
Okay, that's great. I'll have a look at that. Thanks very much, Liz.
Thanks, Liz. And yeah, I'm guessing you don't want to be taking apart your flue from your fire to be doing this. Liam, if you want to unmute yourself to ask your question.
Yeah, I was just interested to know what the thinking is on the dosing of Avamac and chemicals like that for worms. Does that kill the worms in the land when you have a 68-day or 100-day, withheld for meat and stuff like? Beetles are disappearing. Beetles have disappeared completely. Dung beetles around here.
Yep.
And worms are reducing in numbers. And I'm thinking, is there any research done on the Avamac?
Certainly, the work has been done on showing the impact of wormers and also products used to do fly strike in lambs or sheep. So there is some evidence on that impact because basically it's an insecticide you're using on an animal, and you're also obviously the chemical that's going through the animal is then affecting the dung. It doesn't necessarily kill the dung beetle. It does reduce their breeding levels, and that just makes them a bit dozy. So it doesn't necessarily kill them, but obviously it doesn't help them either because the population is reduced. Yeah. In terms of worms, the worms are probably going to be more affected by, so they don't really like compaction, so they'll go somewhere else. And sometimes they'll be helping to improve soil structure, but if there's a nicer place, they'll just disappear. So the worms can be part of it. A lot of it's to do with feed. It's like any animal. Do you mean, are they getting enough feed going into that soil? So that, some of those worms, we have to think from an earthworm perspective, they're not necessarily eating. We think of them sort of dragging a leaf under and eating them. What they're actually doing is dragging the leaf under and then farming the bacteria that eat that leaf, and they eat the bacteria. So it's, for me, the earthworms are indicating, it's a bit like the lions of the Serengeti. They're the apex predators within that soil food web. So if they're not there, something below them isn't there. So ivermectin could be part of the problem, but it's such a wide range of issues, and generally if we're treating animals, they might be in one field, but obviously they're not necessarily affecting. Could be 70% of the farm isn't being dosed by chemicals every week, so it can't just be the wormers that's having the impact. It's other, I don't think they're helping, but it's other factors as well. But the dung beetle link and wormers is really clearly there. Yes.
Yeah, there's something, because years gone by, when you turned a cow pat over, you had like maybe 15, 20, 30 worms under it. Now there might be 2 or 3. You know what I mean? So the numbers are definitely reducing.
Yep.
So
that's sort of the focus on that. We think of the exciting wildlife, but actually, there's what's actually happening to the soils, which is then driving that food web of the higher predators above the ground.
Yeah. Thanks, Liz. Thank you.
Thanks, Liam. A couple of questions in the chat, Liz. Is mushroom compost useful for soil health?
So to clarify, that it's compost that's been used to grow mushrooms. I'm guessing. I'm working on that. So. The answer is yes. Any organic materials is going to be helpful. The key with some of that, particularly when we have high levels of wood chip in those composts, which again it might be, is that it can sometimes lock up. It takes quite a lot of nitrogen out of the system to break that high carbon compost down. So it could be worth storing it, allowing it to break down in a heap before then you're applying it onto land. But yeah, any organic matter generally being added onto soil is going to help.
Okay, thank you. And there's one from Rachel regarding group size and range of stock weights. Can competition be a problem?
Yes, if you're not allocating them enough feed. So if they've got, if anybody's been to see those spring block dairy systems where they're clearly allocating just enough feed for those animals to go into that field. And what happens is they're very competitive grazers. So they're generally within the first 2 hours eating all the grass they're going to eat, because they know the perception is they know there's competition, so it makes them quite aggressive graziers. Where you've got a range of animals in the field, if you're limiting the allocation, obviously the bigger animals are more likely to get that allocation. So it can be a problem, but where you're seeing those really mixed groups, you're tending to see them more on these higher cover systems. So actual dry matter is not normally the limiting factor. It's actually quality that's the limiting factor.
So I have unmuted. Sorry, Katie. Can you hear me? Yeah.
Yeah. We can hear you fine.
So in terms of, if we're going in after 24 hours and there's some grass left, which is what we try and do, we don't make them eat it really tight, then that's probably okay within a range of animals. Yeah, we just find that when we do check weighs, that the bigger, faster growing animals seem to grow at a faster rate than the range seems to get bigger over the summer.
Okay.
So the smaller ones with the lower growth rates
and this tends to be cattle, as in growing cattle generally.
Yeah, growing stroke finishing cattle. Yeah. So I suppose the question is, that probably isn't an answer to this, is what is the optimum group numbers if you've got a fairly tight range of weights? Is it 40 or 60, or is there any work being done on that?
A lot of there is, as you increase group size, it becomes more important for them to be relatively even. Just because there is this more, not risk of bullying, but sort of competitiveness. So where you're seeing people pushing up group size a lot, so we're talking a couple of hundred potentially, depending on the size, obviously the scale of the farm, is they're almost nearly identical in terms of weight range. So for that group, and if you've got the evidence that it is impacting growth rates, then is it worth splitting them up? But in reality, if we've got a couple of groups of 30 or 40 and we're having to do a lot of fencing, then it's quite challenging to justify.
Yeah.
So
yeah, because it takes every extra group we have takes how many minutes a day? Yeah, it all adds up, doesn't it? So one of our aims on your list, on your table, was to I don't know which section it came into, was to reduce the number of groups that we have. So, but I guess that starts at what we buy in, isn't it? That starts at what you're sourcing. So yeah. Thank you.
And I think it is also understanding that there are animals that cope better on those rotational systems than others. So some animals just won't cope with that frequent move. So that's also worth knowing, particularly not necessarily in your system, but if we're doing all grass wintering systems with sheep, we might be pulling out 5% of those animals because they just can't cope with it.
Okay.
So yeah, sourcing a bit of genetics depends on age, experience of grazing, all of those factors come in. But it could be worth pushing up your residuals slightly just to make sure that that's not a limiting factor. But
get that. Yeah. Thank you. Thanks, Katie.
No worries. Thanks, Rachel. Liz, there's a question from Mike. So can competition affect calf growth if you are tight at allocating?
I think it's how we encourage those animals to how quickly they can eat it. So again, the spring block calving system, those cows will eat their allocation very quickly because that's what they've learned. So I think they can learn to be more competitive grazers. But equally, if it was a high priority group that I was trying to grow fast as possible, I would raise the residual slightly just so they have greater opportunity not to be hungry. So residual being when I'm taking them out. If I'm with growing cattle, if I'm going to the field and I'm starting to see those plants have gone very like lime green, like all the leaves have gone. If it's only over 6 hours, not necessarily the problem. But if it's long term that they are eating all of those leaves and we are keeping them hungry for a day, that is when you start to see that not roller coaster, but slight change in growth rates.
Okay. Has anybody else got any other questions? Nobody else has got any other questions. There is just a comment in the chat that James has got. Sorry, James, for not asking your question or asking you to come in when we were talking about the dung beetles. I went to the other questions in the chat first, but thank you very much, everyone, for your questions this evening, and thanks, Liz, for sharing your knowledge and expertise with us this evening. Hopefully, it's all given you all a bit of food for thought as to what you're going to keep, start, stop, and focus on for 2025. Liz is back with us again next week with the title of Making Your Land Work Harder, an integration of arable and livestock. So if you haven't already signed up to that and you want to join us next week, just send me an email, let me know, and I'll make sure you get the links for that. And thank you very much for joining us, and we'll see you again next week. Thank you very much, Liz.
Sorry, Katie, just on one thing, and I'll send it to you to circulate. So this is from dung beetles for farmers or farmers for dung beetles, and that is also showing the level of toxicity, I can't say that word, to products. So it's not saying all wormers are evil, but it's about choosing the product. And also, if you need to use a product that is on the more toxic side, in terms of, they would also provide ideas of how to mitigate that impact. So it is about maybe housing those animals, maybe keeping them on one field, all of that stuff. So it is possible to use it. It's just being pragmatic about how you have to. The other thing is I've also spoken to farmers who are prioritizing dung beetles over animal welfare. That isn't also, for me, is not ideal.
Okay, yeah, no, that's great. Thanks, Liz. So I think we've got a few things that I'll send out with the recorded this time: the dung beetle chemical sheet, the what to focus on for 2025, and then the link for the infiltration.
Yep.
How to do that. So that's great. Thank you very much. And yeah, thanks again, Liz. Thanks everybody for taking your time to join us this evening. And hopefully we'll see you all again next week. Thanks for joining us in our first meeting of 2025, and hope you all have a good week. Thanks, guys.
Thank you, everyone.
Bye, Kate.
Bye.
Thanks.
Thank
Bye.
Thanks.
you.
Bye. Bye. Bye.
Thank you so much.
Cheers. Bye-bye.